Hey sir, this is our end of the year physics assignment. We wanted to include two of the major units that we learned this year, kinematics and energy. So this is our system. It's almost like a roller coaster. It includes a ramp, a loop, and an end portion. The demonstration of kinematics comes through the topics of acceleration and speed. So we know that acceleration changes at different points, and we know that we have two different types of accelerations involved. The one type of acceleration that we have from the ramp itself is caused by the change in motion as the marble moves down from the top portion to the bottom portion, then coming up and moving through again. And the second part of the acceleration comes from gravity, which is mainly in the loop here. So we know that the marble falls because of gravity, but there's also acceleration caused by gravity as the marble moves up against gravity and then comes back down against gravity. So that's the acceleration portion of this. We know that acceleration is caused by an unbalanced force, which in this case is gravity as we release the marble, and that the mass multiplied by the acceleration gives us the overall force. In terms of energy, we wanted to highlight the relationship between potential energy and kinetic energy. So potential energy is in the form of height, the change in position relative to the reference point, which for this entire project will be this whiteboard on top of the table. So the potential energy changes as the marble moves throughout the entire circuit, and you'll notice that it changes twice. Once when it begins at the top portion, where it changes its height originally to the first reference point, and then again when it moves into the loop and changes its position again, going from the bottom of the loop to the top of the loop, and then from the top of the loop back to the bottom of the loop. So how does this explain the changes in speed? Well, we know that as potential changes, the potential changes into kinetic energy. And the kinetic energy is what gives the marble its speed. From the formula, Ek is equal to half mv2 squared. We know that the marble is originally at rest, which is why we can calculate this. We also know that as the reference point as the position of the marble changes in terms of the reference point, it increases in speed for that exact reason. The overall circuit goes from a very high potential to a medium potential and then to no potential at all. And this is what gives us our changing speeds, and you'll notice this in the later part of the presentation.
We designed it specifically in order to be able to calculate changes of speed and acceleration at 3 different points, which is how we also broke up the calculations. 1, the incline of the ramp. 2, the loop itself. 3, the run-out portion of the loop. So, since we know that energy is constantly being lost, whether it's friction, thermal energy, or any other sources. In this case, it's friction. So, this is why we had to start our marble at a height much greater than the height of the loop. Knowing that not all the potential energy from the start of the marble can be converted through the loop, we had to be able to start at a height greater than the height of the loop, which is 30 centimeters in this case, because we know that it would not be able to make it through the loop. So, as a quick demonstration, I will show you the 4 different heights at which we tested our marble. At 1 meter, the marble travels very quickly. At 80 centimeters, the marble also travels very quickly. At 60 centimeters, we see it progressively slowing down because we know that the amount of distance the marble can travel is continuously decreasing as we decrease our height. Therefore, the marble has less time to accelerate, therefore entering the loop with less of a speed. One of the purposes of our experiment was to find the height that yields the critical velocity to travel through the loop. This was found through various trials, which A, the marble had to be able to travel through the loop, and B, the marble may sometimes not be able to travel through the loop. And this height was found at 45 centimeters. This is why. Here we see the marble travels through the loop with a quick stall at the top of the loop, which gave us the idea that it may not continue again, or other trials may not be able to complete the loop. An example of that is how at the same height, trial 2, the marble did not complete the loop. Which is why we can conclude that the critical velocity of our loop at a 45-degree angle is 45 centimeters.